Hi guys, so this is the today's daily practice problem whose name is longest unequal adjacent groups subsequence 2. So the problem goes like you are given a string array words and an array groups and both arrays have a length of n. Okay, so basically they have given a string array and also an array groups. And the question is the Hamming distance between two strings of equal length is the number of positions at which the corresponding characters are different. So basically, at respective indexes, if both the strings have different characters, we will increase the count by one and calculate the Hamming distance. So it is further like you need to select the longest subsequence from an array of indices like this, such that for the subsequence denoted like this having a length of k, the following holds. For adjacent indices in the subsequence, their corresponding groups are unequal. That is, groups of ij is not equal to groups of I of j plus 1 for each j lying between 0 to k. Words of ij and words of j plus 1 are equal in length, and the Hamming distance between them is 1. So both of these conditions are like uh, the respective strings that you are picking up should not be having a similar groups of ij groups value. And the second condition is the Hamming distance between them should always be equal to 1. That is the difference between their corresponding characters must not be anything other than 1. So we need to basically return the string that could be formed like this, which is of the longest possible length. So here is an example like this is the words array, this is the groups array, and the output is BAB and CAB, which is the first character and the third character, because both of these are having different groups value, and the difference between and the Hamming distance between them is 1, right? And BAB and DAB, like the first and second, would also be a valid case because that is also following both of those cases. So in order to code this problem, so the basic logic that we'll be using is that we'll be keeping a DP array, and we'll be using a double for loop and calculating and keep on calculating the value uh, the value which is following the both of these conditions, and if both of these conditions are followed, we will increment the count in our DP array by 1. Okay, so let us code it up. So n is the length of words array. We'll also take a DP array of length n, and we're also taking a before array. This array basically depicts like it will be basically depicting like what is the next, what is the before word, like here the before of CAB will be BAB, that is the before of 2 will be equal to 0 because the character that comes, the string that comes before CAB is BAB, right? Okay, so this is of length n. Now we'll be taking a for loop of range n, and another for loop which will be going on till I. So what we basically need to do is we need to ensure that both of these conditions are following or not. Like we need to check that groups of I is not equal to groups of j, right? This is the first condition, and the second condition is we need to I'm using a function for that, like valid, def valid, which is the function, and I'm taking two strings s1 and s2. So if length of s1 is not equals to length of s2, then we need to return false. And uh, we also need to count like how many for what is the Hamming distance. So for Hamming distance, we'll use this for loop, if s1 is if any character if the ith character at s1 is not equal to the ith character at s2, will increment the count by 1. Then finally we'll return whether count is equal to 1 or not. Now we'll use this function here, valid at words of I and words of j. So if it is valid, we will check whether dp of I is less than equal to dp of j. Right, we'll be changing the value of dp of I only if it is lesser than the value at jth index. So then we will set dp of I as dp of j plus 1, and we will also set before array, before of I will become j. Right, so and we'll also be taking two uh, variables like max val and max index, which is to calculate that which is the last string of our valid subsequence. Right, so if max val is less than dp of I, then max val will be equals to dp of I, and max index will be equal to I. Now we need to find the final resulting array. So we will keep on traversing the loop until max index is greater than equal to 0, right? So in resultant array, we will be appending words of max index, and max index will be equal to before of max index, right? Like max index of 2 will be 0, and at 0 it will go before this, right? So based on this, it will keep on moving to the previous characters. So finally, we need to return the resultant array, and also we need to reverse this array because we are appending the last character first, and then we are moving backwards. So while returning the final array, we need to reverse it. Now let's check it. So it's passing the given test cases. Yes, so it is uh, getting submitted. So now if you observe like what is the time complexity. So if we see that we are basically using two for loops. So the time complexity is O of n square. And if we try to see that space complexity, we are storing the values in a n size array. So the space complexity is O of n. Yes, so this is the final solution. Thank you.